All right, today we're going to talk about iPhone 6 and 6 Plus power management chip, the PMIC. So I'm going to show you one that I just fixed here. This was a rush data that ended up needing a new power management chip. And I've got a few others here that I'd like to change the PMIC on. And we're gonna walk through how to do it, and especially why to do it and why not to do it. So the power management chip, I think, gets a finger pointed at it a lot, and that's unfortunate because it's a difficult chip to change, and it's a little bit dangerous because if you reflow the power management chip, you can really screw up a phone. So let's take a look at the schematic and see what this chip does, unless I have to go walk up front. Let's see, 1 minute, we'll let some people find our stream. Hello, how can I help?
I have a question.
Yep.
Just heard about people.
Okay.
And an iPad that suddenly, that button isn't responding.
Okay. So let's come around over here for a second.
It doesn't always not respond.
It doesn't always not respond.
And I can generally, sometimes if I pick it up, it'll come. And if it won't work, then what I do is turn the whole thing off and reboot it again.
Okay, let's see.
I'm pretty iPad illiterate.
iPad illiterate. That's okay.
I don't know much about these things.
Okay.
But someone said maybe it needed to be cleaned. Is that?
Maybe.
Why didn't it get cleaned?
Let's see. So it's the home button here that you're having a problem
Yes.
with. All right. Well, let's
Over
wake this sucker up and see what's going on.
Okay. How long have you been here?
We've been in this shop for about 2 years,
Oh my
and we do a
gosh.
lot of YouTube. Like right now, you're on YouTube. You can see up there we're in the middle
Ooh, I
of
don't wanna
a
be on
live
YouTube.
stream.
I
Yes,
would've-
exactly. Well,
I
you
would
can
have dressed for YouTube.
dress for YouTube. Yes. Well, you can hide out a little bit
Oh,
here.
you do a lot.
All right. So let's see. So it should wake up if we press this.
No,
And-
it probably worked perfectly for
Yeah,
you.
of course. Just needs
Well,
the
because we
master's
just
touch.
booted it. Now there, see, it didn't.
Oh,
come
I
on.
see. So it
Yeah.
after over time it kind of
Yeah, and,
gets more finicky.
and then it will work, and it's just started it. I don't know what the age of the. What I do most on here is emails, and I read on it.
Yep.
So I don't know if I'm wearing it out.
Yep, probably. So let me show you what they look like inside, because they're surprisingly, let's see if I have one. Probably dig one up. Here's one. Let's get rid of this. So they're a very simple little thing. Do you remember that old game Trouble that you used to
Yep.
play that had the little popper thing like that?
I don't know.
Well, these things are kind of like that. So this is actually just a sticker. I'll take this one off with a little bit of heat. So see how there's two metal contacts?
Yep.
And those have to physically touch these little gold prongs there.
Oh, so it could be getting dirty or worn
Yeah,
out.
exactly. They can kind of get dirty and worn out. Now the button itself is a little plasticky thing. Here you can touch it.
Oh,
See that
okay,
little
yeah.
thing there? And
Yep.
it's just a teeny tiny little thing. So the home button itself is really just a sticker. I mean, they're surprisingly kind of crappy when you look at them like this. So this has to actually push that button. And you can imagine that that would get worn down over time. It can just kind of get old. That button
Yeah.
has to convey a signal to those gold contacts. That's to touch
So
there.
then you can just fix the little button.
So this
and
whole
that.
thing is pretty replaceable. The drag of it is that we have to open up the iPad in order to get in there and do that job. So that's kind of what makes it a bit of a drag, because we have to open it up and take the whole screen off in order to really access
see.
that back part stuff. But if you want, we can, if you want to leave it with us, we can
See,
you
now
know,
it's
yeah, I
not
see what you
acting
mean.
well at
Yep,
all.
it's sometimes not responsive.
And then it ends up,
Yeah.
well, how long do
So
I
here's
have
the
to
thing.
leave it?
One idea would be you could live with it. There is a way you can use software if it's annoying. This itself is a little bit annoying, but we can go to general accessibility, and we can go to assistive touch and enable assistive touch. And see how it makes a fake home button?
Mhm.
That's annoying to use, it is, you know, but this one would at least work.
Yeah, but
You know, it's annoying.
I gotta remember how to do all that.
Right, so this kind of list, that little thing just lives on your screen and you can move it around, and, you know, so if you were reading, or if you were in an app, let's say you were gonna try
Yeah,
to
I
take a
don't use,
picture or something
I
like
don't
that,
use that at
then
all.
you would have to, you know, kind of use this, which itself is pretty annoying. So that's the cheap thing. If you wanna live with it, you could kind of do that. Otherwise, we would have to take the screen off and then replace this whole assembly and put your screen back on.
Okay.
And, you know,
But we don't know for sure that.
well, everything we do either works or you don't pay for it, so
Oh.
that's
Okay.
our motto. The effort for us to take your screen off, though, is kind of expensive, so it's $100 if you want us to lift the screen off and work on that. Your other option is live with it. So that's what we can do for you. $100 to make home button work again, or you pay nothing if we can't fix it.
Okay.
So that's the deal.
Am
Yeah.
I mean, $100 versus a new.
Yeah, or you
iPad.
could go upgrade an iPad. So that, you know, that's a choice. You know,
Okay.
you have to think about that
All
as
right.
well. Now, for you, if you upgrade your iPad, you'll have to get the newer ones have the different charge cables. They come with a
Right.
charge cable,
Yeah,
but
right.
all the ones that you have now wouldn't work with that.
Yeah,
So you
okay.
can think about that. So you can go talk with Sunday, the business manager, and or think about it and come back if you want to do it. If you want to
Okay.
go research how much new iPads would be.
Would be, because I live with it. I mean, I read on it
Mm-hmm.
every night, and
Mhm.
I do. It's not that I do important things on it. I
Right.
just
Yeah,
do.
it becomes a big part of life. I know.
Oh.
All right, Sunday. This nice lady is having trouble with her iPad home button, so I, gave her a quote for $100 to open it up and change out the home button, and she's going to decide whether she wants to just go get a new iPad or not. So you
Well,
can.
what I'm toying with is what else might go wrong with it. Is it worth the 100? I mean, you're opening it for 100, and then if you fix that,
Right.
there's an additional charge probably.
No, $100
Oh,
solve
wow.
your problem.
Oh, okay.
Yep.
It's the whole thing.
Yes.
But I don't know what the life of, if you use your iPad all the time, what's the life of one of these things generally?
Here's the deal with those. They'll last forever if you never upgrade the software. So you know how it bugs you all the time to update your software? And eventually, when they first come out, the hardware, the processor and things like that are well matched to the current software, and so it works really well. And then over time, with newer devices coming out, the software, iTunes, has newer and newer versions that become bigger and bulkier so that the older hardware can't run the newer operating system, the new software. So every time you hit iTunes update, then you're asking your machine to carry a heavier load. So if you just say, no, I'm not going to update, then it stays pretty well matched, the existing software that's on there, and you can use it for a long time. If you like to have the newest update on iTunes, then you can then that's how they really kind of get
How do
aged
I
out.
know whether they told me to update it? I mean, can you tell by looking at it? If
Sure, we can look
if
at it and see
needs
what
to be-
what
I mean, I don't update everything that comes on there. One of my kids was fooling with it yesterday, and he updated some things on there, but
All right, let's see. So you're on 9.3.5, which is good because right now the current version is 10.3. So that
Okay.
means that you've stayed away from updating it to the 10. So I would not update it any further.
well, when
and
you
live
say
with
don't
that.
update it, like if something flashes up and says update, like overdrive, just don't update it.
The apps you could probably update, but in general, I say no to those things because, you know, if
Okay.
it's working the way it is, if it starts to not work, like Overdrive says, hey, I don't work anymore, you need to update, then I'd update it. But if it stays working, then I generally skip those.
Okay. But, all right, well, let me think about it. And
Okay.
figure out- I don't use a lot of my apps, honestly. The
Neither
weather-
do I.
The weather when I update, but,
All right, well, if you wanna take a card, you're gonna look up prices on the newer ones and where you wanna put your money.
All right, Sunday, I'm in the middle of streaming, so I'm going to go back to that.
once I get it to you.
All right, let's see. Okay, so
You're welcome.
thanks for stopping in.
You live streaming?
Yes.
Take a look at this.
Yeah, what's that?
Just fixing the zip. It's a SE. She said little peckers. I just want to make sure before I take
Okay.
the ticket for.
All right, let's look at some little peckers. Well, what's wrong with it? Those are not the little peckers that
She
go bad.
just that's like I pulled up and I picked it up for her and she said it was a little pecker job. So
Those, she is missing little peckers, but those, actually I don't remember. Yeah, I don't remember on the SE which one is the gas gauge. Let's find out. Let's find out. So we're just gonna see, all of these are caps except for one. So we're just gonna put a probe on ground and see. So that one has a photo on ground, so that's a cap. All right, so that one is the filter. So yes, little pecker job.
okay.
And then this one is a cap, and that one's a cap. Yep, so that's the one she needs back.
Okay.
Alrighty, straight up little peckers.
Thank you.
Alrighty. Okay, so hopefully we got ready here to stream about iPhone 6 power management chip. I'm gonna see if I can get comments over here. All right, there we go. Let's see. Okay. Fixed a 6S backlight. Another shot blew out this morning thanks to your videos. That is fantastic. Great job, Brennan. Show me your boom stand on mono. It's right here. I can't show you any more than that. Okay.
Hello. Hi there. Can I help you?
Yes.
Honey, just relax a second.
Okay. So our stream today is about iPhone 6 power management chip problems and iPhone 6 Plus. So this board here is one that I just changed the power management chip on. So let's take a look at the schematic so that we can kind of see what does this sucker actually do. So let's head on over to screen. There we go. All right, so the power management chip is this guy. It is U1202 in the iPhone 6. So let's get some more detail on U1202. What do you do, U1202? All right, so U1202 is a big chip and it's usually split out on a couple of different pages. And on the left side here, we can see a whole lot of VCC mains. The main artery, VCC main, the aorta of the phone is plugging in to this power management chip.
There you go, ma'am. Thank you.
And then let's look at all these outputs. So on the other side, we can see all these different lines coming out. So here's one that is power to the CPU, and it looks like it's a less than 1 volt line. Here's another one that's power to the GPU, which is also less than 1 volt. Here's another power line that is another one of the CPU, GPU power lines called PPVAR system on a chip. And then as we look through here, I'll get rid of the text on the schematic, we can see that PP1V8, another one 1V8 Grape, 1V8 Oscar, all of these different power lines, 1V2, and then all of these bunch of different power lines, 3V3 USB, 3VO TriStar, et cetera, et cetera, et cetera. So what does the power management chip do? What's in common between all of these output lines compared to the battery voltage? They are all less than 3.8 to 4.2, which is the standard battery voltage. So what does the power management chip do? It takes the incoming VCC main battery power and chops it up and deals out all of these little baby power lines. So that's what this chip does. And I want you guys to know, when you're troubleshooting a phone, especially a phone that's just dead, we tend to think the same way. We tend to think that the phone automatically has a short, which isn't true, which isn't necessarily true. A phone can have a short, but it can also have an open circuit, or it can have a dead chip that's not producing either data or power. So that's one thing that people tend to get wrong a lot, is where's the short? I gotta have a short, I can't find the short. Not every problem is a short. The other thing that people tend to struggle with is the idea that every fault is related to a lack of power. The phone's not getting power, it's not turning on, it's not getting power. And that itself is something that you wanna stop thinking. So kind of put that over to the side, because the phone does need to have power. It needs to be plugged in, all the little chips need to be plugged into these individual little power rails. But in addition to that, the phone needs to have data. So it needs to be able to listen to and get instructions. And data, instructions, are just as important as power, voltage. Power voltages going into the chip. So the ones and zeros parts, that's what people tend to not think about, tend to forget about. And so what that leads to is a generalized problem of, if a phone is not turning on, it has a short, and if you can't find the short, then people generally conclude that it's not getting power, and therefore the fault is the power management chip. And that is not the way to diagnose PMIC faults. You don't want to just say it's just, I'm declaring that it's not getting power, and therefore I should replace the power management chip. One of my big criticisms of sort of the please bro solutions that are out there are videos that just get put up that just imply, without thinking, dead iPhone 6, fixed by power management chip change. Well, you can fix a dead iPhone 6. I just fixed one now by changing the power management chip, but you have to have a reason. You have to have you have to have the why behind that before you just go crazy and start to replace this chip. And the reason is because this chip, unlike TriStar, Backlight Driver, or Chestnut, or one of the easier chips to replace, this chip sits directly over the CPU, so it's really easy to overheat the CPU when changing the chip. And it's also really, really, really easy to bridge under the chip. And let's look under the chip on ZXW. So let's go to screen, and let's go over to ZXW, and let's go to iPhone 6. And if we look at the power management chip, and let's just click on VCC main, so we can see that under the power management chip, or within it, there are lots of these VCC main connections. And then there's lots of these other power lines that are being generated by the chip. As we kind of go around, we can see all of these little baby lines that are generated by the chip. Now, we just saw on the schematic that some of the power management chip lines, a lot of them in fact, go to the CPU or the GPU, which is all one chip. And these are very, very low voltage lines. Look at that low voltage. And yet, look at the current, 7.6 amps max. It doesn't mean it goes up to 7 point, but it could. That's a lot of current on a very tiny little voltage. So this line is super fragile. It's extremely delicate. It's going to have incredibly low resistance to ground naturally in order to be able to deliver such a big amount of current, huge amount of current with a tiny little push, a tiny little voltage. So what do you think would happen then if all of these go under the power management chip? What do you think would happen if you were reflowing this chip, for example, reflowing it, you nudged and you bridged the VCC main big 3.94 volts into one of these tiny thin, delicate CPU power lines, what do you think would happen? And this is how you get into trouble with this stuff. So what do you think would happen? If I take 4 volts, that's it's 4 times the voltage that these CPU lines were rated to ever see, and I bridge that into the CPU voltage line, the CPU power line, which that line is like butter. It's like ice. It is able to deliver a huge amount of current with a tiny little push. So if I give it a big push, I'm going to get a huge amount of current on that line. And what do you think is going to be the effect of that? That is going to blow out the CPU. That will physically damage the die of the CPU in a way that renders the phone unrepairable, because the CPU is unique to the device. You've got to have that CPU working. It's hard coded to that phone. So if you run 4 volts into a CPU power line, you will kill the phone. That's why you don't want to take lightly the idea of replacing the power management chip, because it's so easy to do that. If you're seating this big chip, there's VCC main everywhere, and you are seating it in a way that it's supposed to connect to those CPU power lines and deliver that CPU power. If it is off a little bit, one little ball bridged to another, you're going to ruin the phone. And that's why this is a big deal. And that's why we never want to just kind of reflow and nudge the PMIC and kind of hope for the best. So let's really be thoughtful when we think, should I replace the power management chip on these phones? Let's really think about that and have a good reason by understanding, what does it do? So what does it do? It takes VCC main, which is essentially battery voltage, and it chops it up and puts out all of these little baby power lines. So how would we know if the power management chip is not working? We could go around and measure the outputs, the little baby voltages, and see if one of them was missing. And then we'd ask, well, is it missing because it's short to ground, or is it missing because it's not making it to the destination because of an open circuit? And if neither of those are true, then you would point the finger at the power management chip. All right, so let's see, let's catch up here on chat for a second. Let's see. Questions about other phones. Questions about Microscope. Is that an actual customer? Yes, it is. A real person wanting help? Yes. Yeah, that was a staged. Yes, she works here. She knows it. In fact, she's the one that does all those iPad home button changes. Yeah, exactly. Yeah. Yeah, she, let's see. Is it possible to urge you? What does that mean? To stop bullshitting and get to work? All right, let's see. 1V8 always is missing. I changed PMIC, water damage, and dead PMIC fried CPU. It's unlikely that the dead PMIC fried the CPU. It's possible if there was a lot of corrosion under there. But had the same mechanism. If you have conductive corrosion under the PMIC, that has the corrosion has bridged together VCC main with one of the CPU power lines, then you can kill the CPU without really it being your fault. But if 1V8 always is missing and it's not short to ground, it's not open line, then you're right. Then that would kind of point to the PMIC. Burn up the phone. You need to buy CNC to delete power IC. Not for the 6 or 6 Plus. Let's see. When reflowing any IC, check for shorts to ground on all related rails before powering on. That is fantastic advice. What is mobile maintenance? What does that mean? Okay, great. All right, so we're all caught up on here. So let's look at this phone that I just did a power management chip change on. So I just put in this PMIC. And why did I do that? So here's the why on that. So this phone was water damaged, and it didn't have a whole lot of water damage. I did replace the chestnut chip. I tested these lines, and they were not short to ground. I didn't see any water around this part of the phone. The speaker amp was water damaged, but it wasn't causing any problems. There were some bad looking caps here, but they had normal resistance to ground, so I didn't worry about them. And then around this area, when I originally had a low measurement on VCC main, low resistance to ground. It wasn't 100% short, but it was low. So I took off things that showed water damage that were on VCC main. So you can see I took off a VCC main cap here, I took off a VCC main cap here, I took off a VCC main cap here, and then I took off the Stockholm chip. And Stockholm chip has VCC main, and there was a lot of corrosion under the Stockholm chip. And when I did that, my resistance reading actually went down instead of up. So what does that mean? If I'm going around looking for why do I have a short on VCC main, and I'm kicking off caps, and then I take off a chip, well, in order to get the chip off the board, I had to use heat. So I put heat on the board, and now after the board cools down, my resistance was actually less, even though I took a chip off that had corrosion, I got rid of all that. And when you're in that situation where VCC main resistance has gone down when you put heat on the board, that kind of points to the VCC main short being due to a chip rather than a cap, because you're moving around and chunking up corrosion that's under there. All right, so I looked for any other VCC main chips that I could take off, which is why I took off backlight driver, and I took off the Mesa Boost chip here, and I took off Chestnut, which I've now put back, and I'd taken off audio IC, and I still had a VCC main short. Now Mason and Cumulus do not have a path to VCC main, so I left them alone. Ultimately, I ended up replacing Mason, but I left them alone initially. And that's really what led me to the PMIC. I wonder if I still have it laying on the desk somewhere. That'd be kind of cool to find. Is this it? Let's see. Yeah, here we go. So this is the power management chip that I just took off of this board.
Like I said, she had asked about the headphone jack. I don't know. That was just her first initial looking at it. She did that since she was waiting for you, but that's what I heard.
All right, so see all of that corrosion. Now it's really easy to see, now that we look at the power management chip, of why it was that the power management chip was to blame. It had significant gross corrosion under here, chewed up VCC main balls that were easy to see how this corrosion was causing the low resistance, the partial short to ground on that line. And so that's sort of my thinking that led me to take off the power management chip, and then I found that the VCC main line went back up to normal resistance, but of course you need the power management chip in order to get the phone to boot. So I put on a new power management chip, a new Chestnut chip, new Mason chip, and now this phone was recovered. So it's in the done pile. So I'm gonna move that over to the side. I'm actually gonna put it back with its stuff here, because its drive is burning, and that's going to be done. All right, so now let's look at the next phone. This is the phone that made me think, maybe we're going to be doing lots of power management chips today. Let's dig out anything that's a power management chip candidate. So this one's a little bit different. All right, let's see. What is all of this? VCC main jumps to 1.8 volt. If under the power management chip you put VCC main into 1.8, is that what you're talking about? I'm not really sure. All right. Killed with rice and powering on. Well, they've damaged it, but not necessarily killed it. That's right. Okay. And after being said that rice is BS, I typically shit. Surely you want to sell us your expensive cleaning fluid for $50 when rice does it for free? What? All right. What? Okay. Alrighty, so let's look at this. This is a 6 Plus. Now this 6 Plus was also water damaged, and this is the one that I'm currently seeing what I can do. So this one had really very, very focal water damage. So there's really no water damage around here, no water damage around here. The connectors all look really good. So there's no water over here. And then we have some signs of water right here in this corner of the board. We can see a lot of water here at the home button connector. And you can see that I've taken off some components that are around this area that I don't need. In here, there was a lot of corrosion on this backlight cap, but none of this really looked all that bad. I took off the backlight drivers. I've taken off the strobe driver, I've taken off the Mesa Boost chip, and I've taken off Chestnut. And the problem with this foam is that it is in the brain dead category, where it is acting like it can't hear instructions from the CPU. There's really no water down here in this section of the phone. On either side, I've replaced TriStar. Well, let's move that dude back over. I think I'll actually do that now. And all of this work is kind of all subsequent to after the initial cleaning. It did not have any kind of VCC main short, but it was acting like a brain dead phone. And I've moved my DC power supply up so that maybe you guys can see that. Alright, let's look and see what, I didn't notice that before, so let's look and see what's up with that. What's up with that? What's up with that? Move that over. Alright, let me look and see these two guys here. So we'll go over to ZXW for iPhone 6 Plus. Alright. Get X-ray before unsoldering. What? Alright, so we've got this guy was just touching ground, so not a big deal. Alright, yeah, so that's not important for our overall problem. Alright, so let's keep looking at this board. There was a little bit of corrosion on some of these NAND caps, but the NAND lines, the NAND power rails themselves have normal resistance to ground. All right, now the power management chip area itself does not look like water went under it. There's no signs of corrosion around here. There's flux on the board right now, but there's no sign that water went under there. So this makes it atypical. It doesn't look like it would have corrosion under it like that first one did. There is still, it's just really the water was just here on the edge of the board. It was really obvious around audio IC, and that was the first thing I did, was to take off audio IC. And you know, there were a couple of ugly looking caps around here. I took off the Mason chip here because I was trying to troubleshoot why do I have a fluctuating voltage. All right, so let's look and see what is the current status of this phone. So I'm going to show you what it looks like on DC power supply. So this phone, in theory, it should draw a, it doesn't really look like it has anything really deeply wrong with it. It looks okay. I can't detect any shorts to ground. I don't think it has a short to ground. So this would be one of those examples of a phone that doesn't have a short to ground. At least I don't think it has. All right, so I have normal resistance on VCC main, and I have normal resistance on all of the lines that I've checked. So I'm going to connect this. I've connected the phone now to the DC power supply using one of these battery cable connectors available from the iPad Rehab Supply Store. All right, so now this is connected, and I'm going to prompt it to boot by plugging in USB, and then we're going to see what does it do on DC power. So I'm going to prompt it to boot, prompt, and now we can see what it does. So let's look at this DC power supply. So here's where we're looking, and we can see that it has a really low current consumption. So what does that mean? Does that mean there's a short circuit and electrons are running like crazy? Or is this more like a phone that can't hear instructions? This is a brain dead phone, so it can't hear instructions. And so we have to ask, why? Why is it not able to listen to what the CPU has to say? So when we looked at the board, it doesn't look like there's a whole bunch of inline components like resistors that could be washed out, creating open lines so that there's, somebody cut the telephone wire. It doesn't look like that's going on. And it also doesn't look like there's a whole lot of shorts to ground, not that I've kind of gone around and measured. So now let's just kind of probe around and see whether or not we actually have our power management chip output or not. So that means get out a multimeter. So let's do that. Let's get out the good old yield multimeter. All right, so the multimeter, I think you're gonna have to just trust me on what it says. And I can go around and probe, and I can see, let's look at, for example, here. We will pick this guy here, and let's look him up and see who he is. So this guy is one of the CPU caps that I use a lot. And if we go over and say, who you is? Let's see. All right, and so this guy is one of the CPU power lines, so PPVAR system on a chip. All right, so let's look up. So it's C1289. Let's go look on the schematic. Where's 6 plus? I don't think we have a 6 plus. We'll have to open it up. What's this? No, get out of there. Man, I can't read that. It's too far away. You don't have to duck down. That's okay. All right, let's see. Let's find this. So I gotta go on a hunt for the schematics folder. Damn, I am old and blind. Old and blind. God damn, that's hard to see. That's increasingly hard to see. All right, so we're looking for, who was it again? I forget. Let's go back. We're looking for this guy here as sort of our canary for the CPU, one of the CPU power lines. And this guy is C1289. So let's go to the schematic and ask about C1289. I think I should close some of these. Let's get rid of some of these. Close. All right, C1289. No, all right. Find C1289. All right, there you is. So C1289 is on, remember, one of these CPU power lines. And what's the voltage that we expect on this line? We expect it to be 0.9. So it's supposed to hang out at 0.9. And if we follow this line to say, what do you do? Where do you go after this? What's your purpose? What's your job here? We can see that it's supposed to be up to a max of 1 volt. And here it is plugging into, get over there, move, Here it is plugging into the CPU. So this is a CPU power line, and it's supposed to have 0.95 volts on it. All right, so that brings us to our question is, does it? So this phone is still hanging out here in its little brain dead state. Let's ask the question, do you actually have the 0.95 volts that you should have? Because you're supposed to be getting that from the power management chip. So let's find out if we do. All right, so we're going to take the multimeter in voltage mode, and we're going to stick a probe on ground, and then we're going to put a probe right here, and we're going to read it. And what I'm seeing on the multimeter is it says 0.9 for a second, and then it drops. It goes 0.9, and then it drops down to 0, and then it comes right back. So it goes 0.9, 0, 0.9, 0. And that 0.90, I want you to watch that when you look here at what's going on with the DC power supply. So the DC power supply is giving this phone, it says 0.90, 0.9, 0, 0.9, 0. And see how the DC power supply is stopping current consumption, it's dropping current consumption. So it's kind of like the power management chip seems like it's putting out that voltage for a few seconds, and then it's stopping, and then it'll start again right away. So that seems like that's the primary fault in this device. Let's look at another power line. So let's just take a 1V8 around the NAND, for example. So we'll just pick any other power line, and we'll do the same thing. So we'll measure voltage here, and we have 1.8, 1.8, 0. 1.8, 1.8, 1.8, 1.8, 0. 1.8, 0, 1.8, 1.8, 0. Back to 1.8. And then we could measure 3V0 NAND, and it's the same story. So all of these power lines, so it's not just one. I've got 3 volts here, now 0, now 3, 3, 3, 3, 3, 0, 3, 3. Right, so they're all following this same pattern that the DC power supply is kind of showing. It's the phone kind of, starts to boot, it's not getting anywhere, and then it gives up. All right, so now what does that mean? And I really don't know. So in this case, with this history, we can next ask the question of, why is this phone dropping all of the power management chip voltages? It's putting them out, and then it's stopping. So that's either a fault of the incoming power to the power management chip is dirty, so VCC main, which is used to generate all of these things, either that's like really fluctuating and dirty, and the power management chip just can't work with that, so it quits. So that's one possibility. Another possibility is that there's some instructions that the power management chip itself needs to be told by, I don't know, the CPU, the power button, some data line on some chip, I don't know, the Tigris, the CPU, the power management chip may need instructions to be told to continue, like a watchdog pin that has to be, kind of stimulated for it to continue making those voltages. I don't know. So that's another possibility. Is number 2, is that we've got a data fault somewhere where this power management chip is fine, except it's not hearing something that it needs to continue making its output, and so it drops. So that's idea number 2. And then idea number 3 would be that the power management chip is just faulty, that the damage is actually the faulty power management chip, and that's what the problem is. All right, let's see what you guys think before we move on. Let's come up with some strategies to address these 3 possibilities and see if we can figure out something to do. All right, so let's see. Let's go back to, a whole lot of stuff I don't understand. Where did we leave off? Let's see. I'm back a little bit. Anyone from Mars? What? Okay. Let's see. Russian, anyone from Mars? Mars.
So
Most of us speak both Russian and Ukrainian, not me. All right, let's see. Poland, 80 milliamps. Try a hearing aid. Nice. Looks like NAND. What? I2C lines. So I2C lines is a great guess for why are we missing instructions. And that's why I took off the I2C line chip. So both backlight drivers are gone. Chestnut is gone. And I've replaced TriStar to rule that out. And I don't see any physical damage on any of that. And I can see that 1V8 is present and coming out of those I2C line resistors. Check the 1V8 reset line. Should be 1V8 when powered on. 1V8 reset line. Let's see. Language stuff. What? Pepe stuff. Service problems. Fuck that. Whole lot of what? Pulsing. Oscillating, retry, or feeding a short. All right, a whole bunch of people are drunk, I think. It's trying to switch, but not getting a constant voltage. All right, so we have one vote for idea number 1, which is that the power management chip is fine, but it's not getting a good quality VCC main that it can work with, and so it's just giving up. And here's maybe a dead cap switching on line 1, 2, 3, 4, 5, crash again loop. Let's see. There could be a short somewhere detected by overcurrent, and PMIC is cutting power and then retrying after a brief moment. Tough to say if it's faulty PMIC or if it's doing its job. Right, tough to say, and we don't see. So let's look back at this board and we'll see if you guys want to measure any spots that you think could be something going on like that. All right, let's see. The coil is overheating. All right, what? So we've got another vote for power management chip feeds rails 1, 2, 3, 4, 5, and then it crashes feeding rail 6, which would mean that there's a short to ground that we've missed on some rail. But here's the thing with that. So that's this thing that we all want there to be shorts. We want it to be a short. So we look for shorts and kind of force everything to be a short. But if we saw a short, then we would likely see this kind of spike up, and it doesn't seem to do that. So that's what kind of makes that less likely for me, although it could be. And the fact that I've looked on this board and I don't see anything that looks like it would be a shorted line. All right, let's see. You have the power up sequence diagram. I could go hunt that down, but I've never had to open that, so don't know. All right, let's look back then, since a couple of you, we've got, out of the comments, we had one idea, which is that the problem is that the power management chip is fine, except it's getting a dirty VCC main. So let's not prompt the phone to boot, and let's just plug it into DC power supply and let the blood flow. So I'm plugging it in now. So I've got it plugged in, and DC power supply says 0, which is normal because we haven't prompted it to boot. So it's just gonna hang out here for a little bit. So it's hanging out, cooling, maxing, chilling, relaxing, whatever the Fresh Prince used to like to do in West Philadelphia, born and raised. All right, now we can pick a VCC main cap, and now we can measure what does the VCC main voltage look like on the multimeter. It would be better if we had an oscilloscope, but we're not gonna go crazy. All right, so let's stick a probe here. So I'll get to a ground, and I'm on voltage reading, and I'm gonna stick a probe here, and now I'm gonna see, does VCC main fluctuate? And on my multimeter, the answer is no. It's 4.0, 4.0, 4.0. It does not move at all. It's a steady multimeter is not detecting any fluctuation in VCC main. It is a steady volts. All right, so I think that's so that kind of rules out idea number one, which is the power management chip is fine, but it can't work with this dirty voltage that's coming in from VCC main. All right, so idea from the comments number two is that the power management chip is fine, but that it is intentionally turning itself off, which is part of what it's supposed to do when something is wrong. And I'm not really sure what the mechanism might be for that. So a lot of times people kind of assume, this is something that's been kind of funny on the forums. You know, a lot of times folks will assume that, you know, I know everything there is to know about iPhone hardware, and I don't. What I know a lot about is problems that I've already seen, that I've had to really go down the rabbit hole to solve. And if it's a problem that I haven't seen before, so I haven't seen this particular problem before, then I don't know, I don't have any fountain of knowledge. So this is how I think and how I work, is to, you know, kind of troubleshoot problems as we go along. So you can kind of do a little fork in the road here. You could go in the research direction. So you could sit and stare at the power management chip for a long time and try to really understand and guess, and even do experiments on good boards to see what do each of these individual data lines do. And we could come up with what kinds of experiments might we want to do if that's what we felt like doing. If this was, you know, the weekend and we really wanted to call it, hey, let's do research weekend, then we could kind of look and see what's going on. So this is no stuff, so we'll say that must not be important. But right here, here's a line. This is a data line, and it comes from the battery. So battery is talking to power management chip. So we could say, what does that do? Is it possible that the power management chip could respond by turning off to some sort of bad battery information? We're booting off of DC power supply, which does not have that line active, and we know that we can boot off, so we would kind of eliminate that. Crystal problems are a possibility. It probably wouldn't behave like this, but it could. So we could research crystal biology, take crystals off and see what phones did, things like that. These are all outputs. We're looking for other inputs here. This is a V pump, looks like a dump to ground. Let's look on another page. Here is a PMIC where it's thermistors. Ooh, maybe it thinks it's getting hot inappropriately in the wrong way. So this is all data. All right, so we've got all of these inputs to the PMIC, and we don't know which ones of these, if any, have to be present in order for the PMIC to do its job. So this is all CPU talking to the PMIC, and we could research taking a different board and seeing, you know, what about this guy? You know, try start a PMU host reset. You know, where does he go? Likely these lines go from within the power management chip down into the board and directly pop up under TriStar or whatever. You know, here's another one. This one says it's the CPU to the power management chip, system on a chip, hot 1 when low. So we could go, you know, research this. Now the problem with all of the research plans is that it's really difficult to do the experiments. Let's look at this line, for example. So this line here goes from the power management chip, and let's follow it. And it goes to this resistor here. And there's a similar one here. So we could measure on these resistors and see whether or not there's a signal here that is high or low compared to a normally booting 6 plus. So that would be an experiment that we could do, and then we would be able to diagnose, do we have these data line faults? So this is how you would go about, you know, pursuing this stuff. You would look at all of these lines, and you would have to compare to known good to know what is the signal that's supposed to be on them. But there's a lot. So this is a lot of work. This is a lot of work. We don't really have a manual that tells us what all of these data lines are doing. We would have to do research. And in general, that stuff is really laborious. So you have to really want to do it. She minimizes the chat from screen. What? Okay, let's see what you guys think about all of that. Let's see. Politics, power up sequence, high. If there was a short to ground, it would be drawing more. I agree. So that to me puts that down further on my differential diagnosis. Let's see. Wow, on-screen power meter. Yes, the on-screen DC. I'm the first on YouTube with the on-screen DC power supply. Could we not check the output on the PMIC to narrow? Well, we did that. That's what we just did. We checked the output on the PMIC, and we see that it is normal and then drops. Normal, drops for multiple different power lines. So the PMIC is working and then it stops. Working and then it stops. So that's what's led us to why is that? Is it because it's getting dirty power? Or is it missing data instructions? Or is the chip bad? And that's really what every one of these faults boils down to. Is it, not being told to turn on? Is it not plugged into the wall? Or is it just bad? Is the chip itself bad? So we have to figure out between those three. So we did first look, is it plugged into the wall? And it is. So we see that VCC main seems to be steady and solid. So that one we're eliminated. And so that leaves us with number 2, which is it being told to turn off or it's not being told to turn on? Is there some data instructions that it's not getting? And that's where we are now. So we're kind of highlighting what it would actually take to put some time and thought and effort into really researching all the possible ways that the PMIC could be told stop working. And any one of those could be a fault. Now what we would do would be to try to match that up with physical damage. But on this board, there really isn't physical damage. That's the problem. All right. It may see overvoltage from another rail, wrong feedback. So again, that would be in category 2, data. Could be internal short on PMIC then. Well, let's not necessarily the word short. Let's stop using the word short to describe every problem. So we'll just use the word bad, right? Because it could be open, short, or not receiving a signal. So that would be category number 3, which is bad PMIC. Oscilloscope question, is a multimeter with a blah, 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 blah. We don't know. All right, you need to check every single voltage output from the PMIC and see what's missing. Why would I want to do that? Then figure out if it's missing due to short past the PMIC. Okay, what makes you think there's a short here? What on here tells you that there's a short? A short circuit means the electrons are running where they're not supposed to go. What would that look like on here, and does it? All right. Rabbit holes are good for future quick fixes. Well, this to me is not a rabbit hole, and that's the point that I want to make. That you could choose to make it a rabbit hole if you chose to say, I am going to go down the road of troubleshooting all of these PMIC data lines. That's category 2. My opinion is that to kind of go through the hundreds and hundreds of devices that come through in a day, that you don't want to do that right now. So right now we've eliminated possibility number 1, bad VCC main power coming into the chip. And now we're exploring what it would take to really research all the different ways, all the different hypotheses that you could make to say, well, if A, B, C, D, E, F, G aren't communicating with the power management chip, then it might turn off. So maybe the power management chip is good, but the problem is elsewhere, a data communication problem. And the point here is that those data problems are huge. They're really big and they're really laborious to kind of go down that road. So let's put that aside. And then number 3 would be, what if this power management chip is simply damaged? So the power management chip is damaged, then that's why it wouldn't be working. So at this point, I'm going to go with the next step that makes sense to me is to replace the power management chip and see whether or not this behavior is the same. So my point of this video is to try to see a few different examples that would lead you to why should you replace the power management chip. And this is, in my opinion, one of them. I think that we've put some serious thought into this, and we've kind of have a very specific reason, a very specific fault that we can point our finger on, which is power management chip output is normal and then it drops. It's normal and it drops. It's not because of the incoming power, so therefore it's either a data problem telling the chip to not turn on or to drop, or it is an output problem where the power management chip itself is bad. And so this is a good reason to change the power management chip on this device, because we're not going to do it lightly, because it has a high chance of having it being a technical challenge. So you want to have a good reason. This would be a good reason. All right. Make a picture and verify with reference. A resistor may be missing. Well, you don't need to do that. You can just look at it. All right. I can see 4 reset lines on the PMU. If one of them is being activated, I think the PMU will retry. For example, reset 1V8, which can be monitored on test point TP2508. Those are all great things if we replace the PMIC and find that the problem persists, because then that squarely puts us in category 2. All right, so all of this advice is stuff that I think is stuff for later. All right, in and out is fine, so it's the PMIC. All right, let's see. If the CPU was telling PMIC to reboot because of software glitch, could forcing DFU make it stay on? That's a good question, you know, which again would be with data. Software is part of data. All right, and a whole bunch of people wanting to go down the data rabbit hole. Let's see. What is going on? I can't say all that again. A short from 5V to 3V3 rail causes overvoltage detection, no current on DC power supply. What are you talking about? Right. Sometimes there's a strong short after a sequence occurs and the PMIC cuts power off quickly to avoid damage. Yes, it would not show up on DC supply. No, it does show up on DC supply. Yes, if you have a short on PP1V8 SDRAM, you will see it. That's why you use this tool. This tool is great. If we saw a current spike, then we would absolutely go look for a short, but we don't see that. That's the point. All right. Stay on command is not getting to CPU. I think it's not getting to the power management chip. How long would it take to troubleshoot this problem if you did not have a schematic nor a board view? It would take a really long time. It will take a really long time if we're in category 2, and you'd have to then be sufficiently motivated to spend that kind of time doing all of this stuff. All right. Everybody wants to go down the rabbit hole. All right. I think the PMIC just needs power. That's it. Only input except TriStar. It does all the magic after that with the CPU. Green Solo Cup. Okay. All right. So so here's the point. We have, in my opinion, enough evidence that our next step should be to change the power management chip and see whether or not this problem is still present or not. So I'm not, and then we have to kind of, you could spend all day on a board like this, but the point of this video is when should you change the power management chip? This is when I would change the power management chip, which is why I chose to do this video today, because I just had another phone where I had to change the power management chip, which we solved for a different reason. And the reason for that one, if you missed the beginning part, was because it had a partial short on VCC main that was not anywhere else. And when I put heat on the board, the resistance went down and it like stayed down. So even when the board was cool. So initially my diode mode reading was something like 0.15, and then after I put heat on the board, I even put it in the fridge for a little bit because I didn't want to have to change the power management chip if I didn't need to, and it came back to 0.7, which is way too low. It will not boot with that. So for that one, I had, through process of elimination of VCC main problems, that it really had to be under the power management chip, and it was, so changed power management chip to solve on that one because you had a reason to change it. All right, so here's how we're gonna change this power management chip on the 6 Plus. So I have taped a heat sink to the CPU side, and now we're gonna go ahead and get this guy changed. All right, so now we can look around. We really don't see physical damage here. All right, I have to get some new flux out. So I was going to play a joke on Mark. So Mark is up here living in beautiful Honey Eye Falls. So I was going to take this last tube of Amtech. Maybe I'll still do this. I'm going to try to take the label off and stick it on the tube of Chip Quick and see if Mark notices. Don't tell him. He's going to come in, and he has this crazy job. Somebody sent us a 6S long screw damage that screwed the screw in so deep that it went through the board and came out the other side. Like you could wear the board like a necklace. That's how deep the long screw damage is. So if he gets approval on that one, then he's going to stream that on the iPad Rehab channel. So Mark is around for a couple of weeks, so it'll be really nice to have him in-house. All right, let's see if we can peel off this Amtech sticker. And we'll see how much he loves Amtech. All right, so we're going to peel off this. All right, here we go. And now we're going to take beautiful, brand new Chip Quick, the flux of all fluxes, and we're going to stick that label on it. All right, so we're going to do this. Mark, of course, doesn't watch this channel, so he will never know. There we go. Beautiful tube of Amtech. This is Jessa's fake Amtech. All right, I'm gonna use it, and then I'm gonna go stick it back at his station, and I'm gonna switch out the Telltale Chip Quick orange stuff. Now, beautiful Chip Quick repackaged as Amtech, and we're gonna leave it on his station and see if he says a goddamn word about it. I'm gonna vote with no. I think that he will not even notice, but we'll see. All right. What? Digital camera? What are you talking about? All right, so let's put some beautiful Chip Quick repackaged as Amtech on here, and let's take off the power management chip. Alrighty, so that chip is off. And I'm going to get my heatsink away very quickly. That took a little bit longer than I would have liked it to take, but it was a cold board, so what are you going to do? Alright. The chip quick I bought was wrongly labeled as non-conductive. What? That doesn't seem to make any sense at all. Alright, let's... Oh, that's the old dead one. It's all sticky. Alright, let's clean up these pads. Alrighty. Now we didn't see, it's not surprising, but we really don't see any corrosion under here. Not that I can tell anyway. So this is what I do for pad management. I just want to make them all roughly even, puffy pillows. So I'm not a fan of braiding for BGA. There's no reason to do that. I'm a fan of doing anything if you have a good reason. So this chip doesn't need to have like super flat pads. They're pretty, you know, spread out. They don't need to be, you know, like uber ultimately flat to prevent the chip from, you know, kind of teeter-tottering or getting in the wrong spot. So in my opinion, braiding this chip is kind of a waste. All right, actually I think there is a spot here of corrosion. Let's look at that. Yeah, there is a spot of corrosion. So let's actually look up and see with that clue. That could be a red herring, but let's just look up and see who are these guys here, so that maybe we can learn something if that makes sense with our actual problem. All right, so let's go over to screen and see if we can figure that out. All right, we're going to go over to ZXW here and find it. All right, let's see. Where are you? Where are you, PMIC? All right, so let's compare this to where our little tiny little spot of corrosion is on pad number 1, 2, 3, 4, and 5 on the second and third row. So 1, 2, 3, between 4 and 5 on the second row. All right, so what are these guys? PANTC. NTC is generally a word that means temperature sensor. And PMU, probably temperature calibration. Little tiny spot between those two. And then let's look here. This is chestnut to PMU ADC in, but chestnut is gone, so that probably wouldn't likely do anything. And then this is TriStar to PMU USB brick ID. That probably wouldn't prevent it from booting either, but these two. So let's look back here. So this is number 4 and 5. Let's look back and see what we found. God damn it. All right, so let's look back here and see if we can kind of clarify that for you guys. So I pulled off the PMIC, and right here I can see a little bit of, I'm going to heat this up again so that you can see what I'm talking about. So I'm just going to make the flux liquid for a second. And let's make it so that you guys can see this. I don't know if I'll be able to. So there's a spot of corrosion right there. how about this? Let's take it off with a Q-tip and inspect. I don't know if that, I don't think you can see that either. All right, so let's just clean it off. All right, and then let's go look and see on the schematic, what do those lines do? And maybe we'll learn something, but let's definitely get that corrosion out of there. Now, that's a pretty odd spot. I've never seen that before. Definitely never seen that before. All right, so it was right between, right here in this area, right there was a spot of corrosion. Right here, ding. All right, so let's look that up on the schematic. All right, so we were talking about in row number 2 of the power management chip between 4 and 5. So 4 and 5, PA-NTC and PMU-TCAL. PMIC, free spray it to hell. I will not do that. I will not do that. I refuse. All right, so let's see this line. Let's pick this. PMU-TCAL, copy. Now this is just kind of for fun. We're gonna just ask the schematic, search, yo. Delete that shit, paste. All right, here we go. And this is one of the ones that were in sort of our giant section of rabbit hole of category number 2. Anybody in here, at least in theory, could tell the PMIC, bro, you're too hot, or something like that. All right, so PMU, I'm gonna guess temperature calibration, because NTC I think stands for something temperature coefficient, and I kind of think of that word as just temperature. And then over here, these are gonna be, you know, lead to a bunch of these thermistors, and this is all gonna be regulating temperature, which that does seem pretty consistent if you have this line either short to ground or, oh geez, oh shit, I gotta handle that. Or bridged into, I think it was this guy. Let's see, what does he do? Radio. All right, I gotta, hey, what's up, buddy? Hey, what do you need? Yes, what? It's out of gas? All right, I'll try to bring home some gas. Okay. All right, all right, I'll finish this up and then I'll get out of here, okay? And I'll try to get some gas. Alrighty? Okay, all right, bye. All right, we gotta go manage plate heat. Yeah, negative temperature coefficient. All right, there we go. Okay, so kid called and said get the hell home, so let's speed up. All right, so in any event, our next step here is to replace the power management chip, and that is going to have to be our stopping point because I'm starting to get in trouble. And let's take a look here. Okay, so let's see if we are go for putting a new chip on that thing. It looks good enough to me. Looks pretty good. Let's try to match the focus of the microscope with the camera. So I'm going to put on a thin layer of flux. All right, and we are gonna grab another one of my shit power management chips, but they have been working for me lately because I've started to just kind of get used to them. Yeah, like horrible shit. Look at that, horrible shit. But so far, I've used them anyway. As long as you take a look at them. And I think the rest of that is okay. Alrighty, let's stick this on here. Let's get... Now the next thing is to align it. So on other chips, you don't really have to, it's going to snap into place, and this one will too. But you need to have it roughly aligned. So that means you need to pay attention to about how far was it from that row of caps. Was it right up on the ass of these caps like that? Or how was it? So you need to pay attention or look at a known good in order to kind of make that designation. And then I'm going to kind of push it down a little bit, and we're going to see if we can get that sucker on there. All right, so let's get some heat back on here. And I'm going to kind of stay up high. I don't want it to really float too much. I want to kind of warm it up gently. But also, this is a really sensitive area. So this is one of those spots where a minute too long and things go wrong. Or a second too long and things go wrong. All right, so I'm getting the cues from the flux, not from the temperature on the station or any of that. There, it's starting to move on one side. It looks crooked to me. There you go, buddy. That was kind of a big shift, so I hope you didn't bridge anybody. I'm going to give it the imperceptible nudge. All right, imperceptible nudge is done. And we have to let it cool down. All right, so now here's the thing. What I don't want to do is I don't want to have a bridge under there and send VCC main into a line that's a CPU or a GPU power line. So what makes sense for me is to check with my multimeter before I say, oh, let's fire it up. We're going to check to see, do I have a VCC main normal diode mode resistance, which is going to tell me whether or not I've got a bridge between VCC main and anything else that's under there. And then secondly, I'm going to go look and see, do I have the normal resistance on my CPU power lines? So I'm going to take a look at that first. All right. Jessa, make your kids happy more often. You cannot reflux your family. Okay, sure, Pepe. Well, it is summer vacation, and yesterday I went to the CSA and took the little girls and made bouquets and dug up, we picked peas, and then we I took them to Dipper Dan's for ice cream as a surprise. They were over the moon with that. I have been driving kids around tubing on that lake like crazy. And so this kid calls up to say that I need to get gas, that I can continue to drive the same friend that I've already driven around that lake for 2 hours this week. So this is actually the only day that I've been to work this week. So I am not on the shit list for working too much for sure. Alrighty. I took my iPhone 6 Plus because it won't power on, and they tossed it into an ultrasonic cleaner and added alcohol and damaged the power management chip. I don't think they did that. That doesn't make sense. You can't really damage the power management chip with alcohol and an ultrasonic cleaner. Can they reuse, like, reball the power chip? You wouldn't want to do that. That's a lot of variables. Minute too long, things go wrong. Yeah, exactly. Minute too long, things go wrong. Check the other side for solder balls. Great idea. Let's check the other side for solder balls. All right. No, I did have a CPU heatsink. And the new chip does have leaded, but I did have a CPU heatsink one there anyway. I always clean and reball my PMIC with leaded. Cut down on heating time. I order the shit ones from China that come with leaded. Fuck the wick. The wick's a bad idea. Definitely a bad idea for this repair. Look how easy this was. All right. Okay, so let's see. Let's see if we have to live in shame. All right, so let's check for solder balls popping out. Do we have signs of excess heat? Answer: hells no. No, because I'm a pro. All right, now let's see if we now really have to be shamed when we have a VCC main short, which is entirely possible because that chip did have a significant shift, a bigger shift than I would have liked him to have. But plus, he is a pretty crappy chip from my strip of crappy chips. But let's see. All right, VCC main result 0.331. So that is normal. All right, now let's go back over here and we're going to check our diode mode readings on our canary caps. These are the guys that are going to be right near the CPU. How about you, bro? He says 0.230, so that seems normal to me. This says 0.04, which is normal. Ooh, oh right, oh thank God, that scared the shit out of me. All right, and this one is reversed in between the 6 plus and the 6. So this guy is I believe the 1V8 rail. So I think this is ground in the 6S, but in the 6, this side is ground. All right, so this one is lower than it should be. So this is 0.041. So let's see. Sometimes that kind of comes back up on its own. But let me check on that rail and make sure it's the 1V8 rail that I'm thinking it is. Because it might not be in the 6 plus. All right, 6 plus. Who are you? Who is you? Who you is? Yeah, this is the ground side, I'm pretty sure. Yes. And then this is the 1V8 SD RAM line. And 1V8 SD RAM line should be, at least in the 6, it's something like 0.1 something. No, it's not. It's like 0.3 something, I think. That one is. 0.2 or 0.3. So that needs to come up significantly, or else it means that either the Chinese chip is bad or it means that we have some kind of a bridge there. So I would not want to put power into this phone. I would not want to put power in that phone into the phone unless I could confirm that I am good on my CPU power rails. All right, let's see. Let's see. I was supposed to get a whole lot. I have like 3 other PMIC jobs here that I really wanted to get to. Grr, 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 grr. All right. So let's see. And in my experience, a lot of times these lines will cool down and they will come up significantly as they cool down, but I don't really know. Yeah, that's still pretty low. So I'm a little bit unsure whether I definitely don't want to put power into this phone. So I'm unsure whether I want to just go ahead and replace that chip again or not. Or let it cool down and see if it comes back. Probably should replace it again. That would probably be the fastest thing to do. All right, let me think about that for a second. All right. Let's see. Kick it with 6 volts. What? All right. A minute too long. Things go wrong. Maybe. Gas in the green solo cup. That is pretty funny. I did have... Now these are leaded PMICs, so I'm not going to reball the leaded PMIC with leaded. Not doing that. I'm not going to freeze spray anything related to PMIC. Alright, I think the fastest thing to do might be to... Yeah, that's gonna stay. Alright, I'm gonna change this again. God damn it. Hello? Alright, so let's stick a heat sink on here. And let's do that again before this board cools down too much. Alright, so we're going to rip this sucker off. Now my goal here when I lift it up is I want to see, did I actually have any bridges under here? So I'll try to lift it straight up this time so that I can see the bridges. Did I? Did I? I would hope to find a bridge, otherwise that could be bad news. I don't see any bridges. Alright, so let's go ahead and clean up these pads again. I've been having pretty good luck with my cheap, crappy PMICs. You know if Sharon's coming in tonight? I guess she doesn't, isn't it? Like, yeah, it's Friday. Okay. Then I kind of have to put back together this data job that's done. Is Mark coming in tonight? Alright, looks good. Balls look good to me. Alright, last PMIC in this strip. Huh? No, I'll just ask him later. Alright, I'm going to slap my heat sink back on here. And then flip this sucker over. That one ball looks a little bit high. I don't like that. No high balls. There we go. You need to wick. No, I absolutely do not need to wick. I damn sure don't need to wick. I do need to remember which one is the PMIC that I'm putting on and which one is the one I'm taking off. Alright. China's finest. Alright, let me go with that. What temperature do you use the hot air at? No, a cap is not going to go short, and this is either, you know, the cap will not go short for no reason. And that doesn't make sense. If one V8 is short despite this, then it's going to mean that it's short within the CPU. It would be heat. Caps don't just decide to become wires from heat. They do that because of electricity, and they do that because of drop, and they'll do that because of water damage corrosion. But they're not going to just be fine 1 minute and then a cap decides it's going to be a wire just because you put heat on the board. But chips, especially underfilled chips, they don't like heat. So if you have a problem that you didn't have before and you put heat on the board, it's going to be a chip. Alright, imperceptible nudge is done. Kick off the heat sink. And let this cool. Alright. Ooh, we do see a little solder ball. Boo! Alright, we'll kick those out. Okay, now this one is what it is, and either way, it's time for me to get the hell out of here. Alright, so we have to let that cool for a little bit. Let's see. You need to wick. Let's see. Coming from a chemistry background, I don't have a chemistry background. Do you treat electrons as valence flow when visualizing board faults? No, I don't think about electrons at all. All right, maybe you remove the bridges with a chip. Nope. I mean, the alternative here is that this is the same, kind of PMIC fault, which is, let's look at 1V8 line. I'm pretty sure that 1V8 line goes under the CPU, which would be the most likely case here. All right, microscope, let's look and let's see. Yeah, so there we go. See, look, CPU, right? See, ring around the CPU. It's right on the edge, right on the edge. That is, where heat can go. You get one of this little things here kind of touching somebody else, that's bad news. So that would be the alternative, is that this ball here or that one, in fact I've seen it in that one before, or that one, that those guys are touching the neighbor. See, look at that. Bing, bing, ground, 1V8, ground, 1V8, ground. That is the likely alternative. And that's pretty likely here because we didn't see any kind of bridging. So I wanted to see, a bridge between 1V8 SD RAM under here and anything else. Wanted to see it bridged because it wasn't as full short down to 0. Like I was hoping it would be bridged into some other line like that. But that I didn't see any bridges. So the likelihood that this is going to continue to be a SD-RAM 1V8 short is high, but we'll see. All right, you need to wait. Nope. Check caps now without PMIC. Nope. Check cap for short before replacing PMIC. Could be cap gone short. Nope, doesn't make sense. Wicking is unnecessary risk. You got it. What temperature do you use the hot air? I use it hot enough, possibly too hot. Shouldn't you test it without the PMIC? Nope. What? That's right. Why not wick? It is an unnecessary. Why wick? How about that? Why should you wick? Wicking could pull a pad. That's right. And if you do pull a pad, you could really ruin things. Really look at a wicked pad. What does it look like? Does it look like a beautiful puffy pillow that's a substrate ready for a new chip? Does it look like the way a chip would have natively gone on, which is sitting on paste? No, it looks like a cobblestone dry ass pad. It looks like sandpaper, and sandpaper doesn't really make good joints. So wicking, in my opinion, is a bad idea for BGA work. All right. You have success always clean only with iron? Yes, the last one I just did 10 minutes before I started the stream. Just do them always the same. Solder balls, yep, balls all over the place, exactly. All right. Heat is electricity. IR biology, okay. Biology was saying something else, what? Don't forget to put the fluxel marks this. Yes, this is the important thing. You go switch this out. Let's see. What is all this Pepe stuff? I don't pull pads. Well, so what? That's like saying that's like saying I speed, but I never get pulled over. Well, it doesn't make speeding a good idea. Oh shit. Hey Mark, how's it going?
Good.
How's the house?
Awesome.
Great. Well, I'm just gonna check to see if I have a 1V8 SD RAM stored, and then I'm getting the fuck out of here because I have to go pick up some gas. I just need to borrow this for a second.
Okay,
I'll put it right back.
I was worried that you were putting my tweezers back.
No, I would never touch your tweezers. No, I wouldn't.
So what are you doing tonight?
Apparently dragging some kids around the fucking lake again.
All right.
Fucking kids. All right, let's see. All right, what do you think? Do you think this is gonna have? I've been doing a whole bunch of PMICs. All of them have been working great until the one I decided to do on stream.
Well, it's gonna work now because I'm here.
Oh, okay. Did you want to put your hand on it? Did you want to like just? Do you want to just like rub it a little bit? So what'd you do yesterday for your birthday?
I fixed some stuff.
Awesome.
And ate food.
Great. Did you guys go to Dipper Dance? That's what I would that would be my recommendation.
I mentioned that today to Cecilia. We just got back from shopping. We're gonna take Max there.
Yeah. Yeah, I took the girls yesterday. They loved it. All right. And now for the exciting failure. We are going to first, let's see if we have a VCC main short or not. How are we doing? Which is really my number one tell for PMIC placement. This board still is a little bit warmer than I'd like it to be. 0.206, that's low. All right, low. All right. Which, honestly, I think that chip went on totally fine. So that one I would kind of blame the Chinese chip, but what do I know? 0.208. Not good. Can't test. But let's see what's going on over here. Let's see. How are we doing? How are we doing over here? Yay! We solved that problem. Ha! But we grew another one. Goddamn piece of shit chips. All right, so we're back up to normal. Yay! So we're at 0.307 on our 1v8 SD RAM line. So that healed itself. All right, one of these or the other side, I don't remember. Yep, that's normal. And that's normal. Hooray! Now, since this is a little bit of a tough one because I'm trying to think, is there this guy could, I'm trying to think, there's a lot of VCC main ugliness on here. So before taking off yet another power management chip, ooh, yes, I see a fucking bridge. Yay, hooray, it's the best day ever, hooray. All right, let's go ahead and clear that. Yes, things are looking up and up. All right, and I need to get the fuck out of here. All right. Sam had to call me. I blame the old lady that came in here and took up a bunch of time. All right, this is great news. We're gonna clear this bridge. All right, we're gonna clear this bridge, and then after all that, we're gonna be back to nope. It wasn't the PMIC. It's still. Have you ever had one, Mark, that like is fine, and then it just kind of like drops? It drops PMIC outputs for no reason, like periodically, like every couple of seconds?
I have not seen that before.
Yeah, me neither. Well, if this has solved itself, we're going to blame one of these temperature things. Get out there, piece of shit. Come on. Separate. Break it up. Stop fighting. Stop that. Stop fucking around in the back seat. Awesome. Let's see if I can just move that with tweezers. Okay, and now let's see if, I don't even know if that cap was VCC main. I get confused between the 6 and the 6 plus. All right, let's see. How are we doing? VCC main. Yay! 0.333. Back up to normal. Excellent. So now we can test. So we have 0.335 on there, which is good. And we have a good reading 0.25 there. We've got our 0.05 there. Oh, thank God, the ground side. And 0.308. So we have fixed our 1v8 SD RAM short, which is great. And now let's see if it made any bit of difference on DC power supply. All right, so let's see. I could hand this stream off to Mark. Mark, why don't you go down the rabbit hole? Now I'll figure out which data line is it that's causing this thing to... That'd be awesome. All right. He's like, I have other plans. All right. Use that damn braid. I will not braid. I will not braid. Okay. Okay, now let's see. Are we still, for you guys that haven't been watching this whole stream, are we still where we were, which was an iPhone 6 Plus with water damage that had an odd fault that is power management chip output, so multiple lines that are PMIC output, would have a normal voltage for a few seconds and then drop. Normal voltage and then zero. Normal, 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 zero. Normal, 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 zero. And so we talked a lot about the discussion of how, when, and why. You know, do you know to replace the power management chip on the iPhone 6 Plus? So for this one, we replaced the iPhone 6 Plus power management chip, and now we're going to see if we still have a brain-dead phone. Is it that those power lines to the CPU are still not staying on and waking up the CPU, and so therefore kind of nothing happens, and that shows up on DC power supply as 0.0 something volts. All right, so let's go ahead and hit prompt to boot. So we're hitting prompt, 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 and then we're going to let go. And it's doing absolutely nothing at all. All right, let's hit prompt again. Prompt, prompt, prompt. Zero, completely dead. Now, really being 0, 0, 0 is kind of hard to do. That generally indicates a, you know, a problem like you're not telling it to turn on. So let's see. Let's reconnect that. Reconnect this. Prompt. Yeah, so it's really not responding at all to USB input. It's really not responding at all. So that is like it's not even trying to do anything. So let's go ahead and go over to the power button input and see what that does. So we'll kind of come down here to the power button, and I can't see my DC power supply. Only you guys can. I have to see it through the camera. That's kind of hard to do. All right, so when I don't see it doing anything, so I'm trying to prompt it to boot at the power button, then the next thing I would do was I would look back and see. Actually, I don't know on the 6 Plus where is the 1V8 always line that really is the power button. Let's find it. Let's find it. Let's find it, and then I need to get out of here. 6 Plus. Let's look for 1V8 underscore always, or just the word always. 1V8 always. All right, so we can simulate the power button by making that line go to 0 for a second. So we can find it here. Let's find R1403. So let's ask the XW, where is R1403? Where are you, R1403? Come on, let me click it. This side. PP1V8 always. So any of these dudes, which are at the very, very edge of the board. So let's look back at the board and see where those suckers are. All right, so they are on this side of the board. And let's find those guys. All right, so these are, let's see, very, very close to the edge. Somewhere around here. 1V8 always. All right, so there's this little, let's see. It's kind of over close to the first laying down one of those guys. All right, so I think that right here, that guy, this guy, can go to ground. And let's see what happens. All right, does DC power supply recognize that at all? Let's try to get some tweezers on there. Does it seem to recognize that? Nope. Does it seem to recognize that? Nope. All right, so that means we need to measure with the multimeter to see, do we have 1V8 always, which should be produced by the power management chip, and is it 1V8 always? All right, are you there, bro? 2.09. 2.05. Aren't you supposed to be 1.8 and not 2? All right, let's see what VCC main is. .9. All right, let me look back. Which ones of these are? This side is the power button side, and that side is 1V8 always. All right, so the one that is kind of all by itself. All right, so what I'm looking at here is right here, this little resistor. This side is the hey, power button, and this side is 1V8 always. So I should have a voltage here that is essentially the power button voltage. So let's measure that, and it looks like I have this odd 2 volts there, which really it should be 1.8 and not 2. It shouldn't be 2. It should be 1.8. All right, so let's measure that. All right, so on the one side we have 2.09, and on the other side we have 2.05. And in any event, I'm going to use my tweezers to short that to ground, which is the same thing as touching a power button. And while I'm doing that, I'm looking at DC power supply to show me a response. So shorting that line to ground should cause current flow to happen. All right, let's see. What is this? Donated $100 to Lewis, so I have to be fair and donate $100 to Jessa. Yeah, exactly.
Yeah. What about Mark?
What about Mark? Let's see. A short to data not causes current. What? Okay. Chris, you can have $13.37. Chris, she rich does not need my money, correct? No, that's not correct. And that's really getting annoying, to be honest. And in fact, the last message I have from Lewis is screaming at me that I need to address this misconception, blah, blah, blah.
The misconception that he perpetuates?
Yeah, that he perpetuates. Exactly. Yeah, the last things from here is you need to confront this, blah, blah, blah. He said copy and paste this. I have a lot better to do, like teach and find new flaws in devices before everyone else does at 1 a.m. Every now and then I decide to take a vacation from torturing myself to enjoy lights in the sky. Explain what you find wrong with that. Blah, 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 blah. And then he was pissed that I didn't actually copy and paste that. Yeah, no. Here's the thing. This is annoying. I recently moved houses, and on the day that I closed on a nearby lake house, which by the way is 2 doors down from my employee's nearby lake house, I wrote a big check for the down payment for that house. The check that I wrote was equivalent to the paycheck that I've never drawn. I've never taken $1 out of this business. And I still haven't, because I took the money that I've made by teaching myself board repair, teaching others how to do board repair, doing free YouTube content, I've never taken a paycheck, and I took this money and I invested it into a house that I intend to use for more business growth, which is to have a lodging option for students that come to practical board repair school. And I did that. And on the day that I closed on this new house, which really is kind of a big deal, there was somebody's rush data job. Hey, somebody donated $75. Paul, thank you, Paul, and I appreciate that very much. But the day that I closed on that, which is a big deal, you know, where you've kind of like get to the pot of gold, the dream, you know, to you know, buy this house that's on a lake. That night, I had to do that MacBook job. I was sitting in this chair on the day that I had moved furniture in there and had set everything up. I had to leave in order to come here because it's my business. I'm the boss. Nobody else could do it. I sat in this chair on the very day that I had closed on this lake house, and I sat here and I fixed iPhones, and I fixed the MacBook for the guy that was really in a hurry that needed it to go out the next morning. I fixed that until 4 o'clock in the morning. And that's sort of what life's work. If you know, this idea that sort of Jessa is rich is really annoying, and I would prefer to have the perception be, you know what, Jessa works really fucking hard. Jessa works really fucking hard and has sacrificed a lot of moments out of my kids' lives, like even right now, and has sacrificed a lot in terms of, you know, like every small business owner does. You become obsessed and you work really, really hard in order to, you know, provide jobs for people and being able to provide content that others can use for free to do more business and fix more devices, and to provide customers a value, you know, so that folks can come in here and not have to go buy a new device when they just need a TriStar chip, you know. And a lot of this stuff it gets really annoying, honestly, when I see all of these comments that are, yeah, she doesn't need my help, you know, that kind of stuff. And a lot of that kind of started with teasing from Lewis. He is my best friend, and so he thinks that's hilarious shit to kind of like make this shit up. And you know, he is very good at that, but it is definitely getting annoying. All right, so thank you to those guys that donated. Somebody donated, not as rich as Paul, but willing to support always. Well, thank you for that. All right, and now I would like to troubleshoot this more. It's odd for the power management chip to be putting out 2 volts on 1.8. It should be 1 V8, and it's usually really tight on 1 V8. But this power management chip is putting out 2 volts. That's very odd. And it is, you know, I don't think that I have any connection problem here, but a device doesn't ever really do 0. 0 generally means something is not hooked up well. So we will see about that. So this one is a fun one. It's definitely interesting. That temperature coefficient thing was weird. And I think that power management chip went on fine, and we've measured the diode mode readings around it, so I'm pretty confident in the placement of that particular chip. Yay, we got some SEKs, $100 to take my money, Goddess of Repairs. Well, thanks guys, that I really appreciate that, I really do. So this one, I think we'll do another PMIC stream, because I've got my other really interesting one that I kind of want to get back to, and then I've got another one that just needs to get a new PMIC from a prior repair attempt, one that's botched. And I've got a stack of a couple others that may need PMICs, I don't really know. But anyway, I like this video about thinking why. What does it do? Why do you need to change it? and sort of the what not to do, which is to see. It's a tough chip that you don't want to just kind of willy-nilly just take a stab at it without having a really good reason to change PMIC. So
Don't change it because Deep fixed it.
yeah, exactly. Don't change it because Deep fixed it. Hey, Mark, just before I leave, what are you working on right now?
Long screw damage.
How's it going?
That's going great.
Have you soldered any traces yet?
Not yet. I don't think I'm going to have to on this one. That's how great it's going.
Okay. Well, let us know when you solder some traces next. All right. Let's see. Okay, is there anything else that's in here? Jessa must drink a lot of coffee. Nope. All right.
Oh,
Yes, exactly.
yep.
Ooh, are you getting ready to solder a trace?
I am.
All right.
You want me to come do it up there?
Yes.
Okay. I got to do two traces.
Okay, cool. I'm gonna move this out of the way. Yeah, let's see your long screw damage. All right, let me put this with this.
Oh, you got so many things going on there.
There you go.
All right, so we got bottom right side, iPhone 6. The easy one.
Mm-hmm. Now, did you bring your UV light?
Oh, damn it.
Gotta drive back to Florida.
No, I have my brother is house sitting, and I need him to send me Max's birthday presents that we forgot to
Oh,
bring.
jeez. Oh.
So I'll have him toss that light in there with it.
All right. Do you need trace wire?
Nope, I brought my
You
own.
did bring your own. Okay.
I know what's up.
What?
I'm not going to be up here digging through stuff for 5 minutes.
Are you on? You're not on mini hot tweezers. D. Mark knows what's up.
I know what's up.
I'm gonna be digging through comments.
So, did you go strawberry picking?
No, not yet. Does Cecilia want to go?
She does.
Okay.
She didn't want to that morning.
Yeah.
It was wine. The Lambrusco was good.
Lambrusco. Oh my God, that's like my dad's favorite.
That's her favorite.
Really?
Yeah.
Seems to be going pretty well, Mark. You're a total pro.
I've done this once or twice before.
Okay. So if you have to end up doing the one that has a hole in the board, how many traces do you think that's going to be?
I expect somewhere in the range of like 20 to 30.
That's a lot.
My plan for that is if he wants to go ahead with it, go like 5 layers deep, kind of in a cone, like
Oh, okay.
like when they're strip mining a hill or
Yes.
something, and then do the same thing from the other side.
Yes.
I think I can make it work. I hope he wants to do it because I kind of want to try, even though it's going to be
Yeah.
a nightmare.
Yeah.
It's a challenge.
It's a challenge. It's interesting and fun. Now, do you reball PMICs if they are not leaded?
I haven't.
I haven't either. That's what they do in the South. UV light? Yes, UV light helps you see where the broken traces are. Ooh, Mark, you got a bunch of SEKs.
I got a bunch of sex.
You got a bunch of sex. This is for Mark. Give him the money. Will do. We have to look up how much sex that is.
Thank
Mark
you.
just got paid in sex. Go home and tell Cecilia you got paid in sex today.
All right.
Mark,
Come
of
on,
course Mark
break
can get
off.
this one to work. Mark's like 100% success rate. He never fails.
Yeah, long screw damage is.
That's his thing. He's
Yeah.
the king of LSD.
It's boring now. I've done so much LSD, I don't know what to do.
All right, so how's that? Are you ready to test?
Yeah.
Yeah?
There's I got 6 parts back here. Yeah, so this was sent in as no backlight, but obviously it was no
Image.
no boot.
Mm-hmm.
So we're gonna see an
Are
Apple
you
logo.
liking that
and then-
Amtech? It's the new kind. I wasn't sure if it was fake or not.
Yes, I do like the Amtech.
You do? Huh.
Wait, which Amtech?
The one you just used.
This one?
Yeah.
Oh no, that's Chipquick.
No shit, man, but you said you liked it. Just to be clear, everyone, this is dun 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 dun.
I thought you were talking about the tube I have back there that
That
we
is,
got
you
last
just brought
month.
this from back there. You walked up here because I went and planted it back there when you first walked in
I
here.
have
That's the whole
legit
point.
Amtech back there. I knew that was Chipquick when it's obvious. If this
You
needed,
didn't say a goddamn word about it,
If
and when I
this-
said, how's that flux, you said, great.
if this was
Case closed.
if this was an iPhone 6 Plus, I would have refused to do it until I located real Amtech. But because I only had to do 2 traces, the garbage Chipquick is acceptable.
That is the lame response to our extreme effort that we went to trick you. You see that? Look, we put a fake label on this just now.
Yeah, that was a lot of work.
Yeah, it was. We had to heat it up so you wouldn't notice.
I noticed. I knew it was Chipquick.
So just to be clear, Mark Schaefer said that this flux here is fine.
it's
and
acceptable.
He just used it, you saw, to do a long screw damage repair. That worked.
It is acceptable if the job you're doing is very simple and you don't
It's
need.
so simple
you
that
don't need a
Chris
good
Long
flux.
said, I'll be surprised if you can fix that, Mark. Dun, 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 dun. Mark's favorite!
I could have done.
Recommended by this
I could
guy!
have done that job with Kingbo.
Oh yeah, take it off, do it again. Alright. Alright, I gotta get out here. Okay, so let's see.
It's still booting. There we go. It's out.
Yay!
Does touch work? Yes, touch works. Thank God.
Yay! Great job. Alright. Let's see. Well, thanks for all these donation guys. That is
Yes, that is
that
very
is
kind.
Very kind. All right, I'm glad I'm not wearing my headphones. Whoops. All right. He said, "I know what's up." He said he knew what's up, and I was afraid that he knew what's up. But then he
No.
said, "I know what's up. You like," and then he's messing with the soldering station, changing it to.
You didn't trick me with the Chipquick. It was
Yeah, we
obviously Chipquick.
We'll see. All right. Okay. Okay. So we're done. That here. We want to look at that again. Look at that beautiful repair performed. Brought to you by Chipquick. Chipquick, the amazing flux that all the pros use to do difficult repairs. Endorsed by Mark Schaefer. And that's it for today.